Hey guys, welcome to another low budget screencast by Mrs. Peters. This one is going to be the 5-7 General Solutions to Trigonomic Equations lesson. You can follow along and take notes as you go, pause if you need to, whatever. Because I know you can pause, I'm going to go at a good pace so that nobody gets too bored. So if you have to re-listen to something, then do it. All right, so what we're doing here is we're solving trigonomic equations, and you've already done some of this, so it shouldn't be too big of a stretch. We'll start out pretty simple. We're going to say the sine of some angle is -1/2. So the easiest way to go about this is to do the inverse sine of the value that you're looking for. And of course, you could also use your special right triangles, but if you're feeling a little lazy, throw it in the calculator and it's going to give you -30. Okay, and the directions specifically said the angles are going to be from 0 to 360. So -30 is not going to work for us. But let's look at -30 right here and figure out where else we can draw an angle with the same sign. Sine's the y, so I know that I can draw an angle in quadrant 3 of 30 degrees, and it will have the same y coordinate. So that angle is 180 plus 30. So I know 210 is a possible answer here. Looking at the original angle that I found, this is 360 minus 30. So this other angle is 330. And those are the two possible solutions. Okay, let's move on to the next question. So in this question, we have a step to do first before we can take the inverse. And that is, we really want to isolate the cosine. So we're going to subtract 5 from both sides. So we have 0 equals cosine of theta. Okay, now you can throw that in your calculator of the inverse cosine of 0. And we already know what we're going to get out. We're going to get 90. And remember, the calculator only gives you solutions in the first two quadrants for cosine. So 90 is one possible answer. Don't forget, cosine's x, so that means that right down here is also a cosine of 0, which is 270. All right, moving on. We've got a step outside of our sine, so we're going to add 4 to both sides. All right, now -9/2 is really -4.5. So when I go -4.5 plus 4, I'm going to get -1/2. So that's equal to my sine. So I can take the inverse sine of that. So the inverse sine of -1/2, and let's throw it in the calculator because I am feeling lazy, is -30. Okay, let's draw -30 right here. So we've seen this one before, actually. So again, we have 180 plus 30 is one of our answers, and 360 minus 30 is the other answer. All right. All right, tangent. Tangent's a little bit different. If you think about the unit circle and the angles around the unit circle, if I draw an angle right here, the x and y coordinate is going to be the same absolute value as the x and y coordinate over here, but the signs are going to be different. In this case, both signs would be negative, whereas in the first quadrant they were both positive. Now remember that tangent is sine over cosine, which means in this case y over x. So if I take the y over x over here, I'm going to get something positive, and here, this negative y over negative x, I'm also going to get something positive. So the tangent of this angle here has the same tangent as this angle here. So really, when you want to find that other tangent angle, you just extend that line. Okay. So let's look at this problem then. The first thing I want to do is what I was doing before, which is to get tangent alone. So I'm going to divide both sides by 2, and then I have -1 equals the tangent of this angle. So inverse tangent of -1. So calculator will do that for us, or you could use your triangles, and I know my answer is -45. So let's draw it. Here's -45. So where else can we find the tangent, or an angle with the same tangent? Just extend the line right across, and I got a 45 there. So now we have to write these angles with relation to 0 to 360. So that would be this angle right here, which is 180 minus 45, so 135 is one of our angles. And then we have another angle from 0 to this -45, which is 360 minus 45. So that would be 315. So there's your two answers. Okay, so we're going to get cosine alone, and what we're going to do is we're going to divide both sides by -2/5. So -√3/5 divided by -2/5 equals cos theta. Remember that division of fractions is the same as flipping and multiplying the second fraction. Oops. Got to flip the fraction. All right, so -5/2. So the 5's cancel, the negatives cancel, so I end up with √3/2. All right, so I'm going to be taking the inverse cosine of √3/2. Okay. So when you throw that in your calculator, you're going to get 30. Let's draw our angle. So 30. So remember, cosine's x. So where else can we draw an angle with the same cosine? It's going to be right below, because x is positive in quadrants 1 and 4. So one of our answers is going to be 30. And the other answer is going to be 360 minus 30. So going this way, 360 minus 30, it's 330. Okay, so things get a little bit different here because this right here tells me that we're working in radians. You're never going to be told put your answer in radians, but you have to notice the 0 to 2 pi and know that you're going to need to do that. Okay, so let's start by adding 4 to both sides. So -8√3/2 plus 4 equals sine theta. You might notice, oops, I have a plus right here. You might notice that 4 is actually the same as saying 8/2. Oops, 8/2. So when you have -8/2 and you're adding positive 8/2, those things go away. So √3/2 equals sine theta. So the question is, which angle has a sine of √3/2? If you put it in your calculator, you're going to get 60, which we know is pi/3. Now, where else can we find this angle? An angle with the same sign, right here, pi/3, which is 3 pi/3 minus pi/3. So our other answer is 2 pi/3. Okay, now you could have used 60. You could have said, okay, this is 60, this is 60, 180 minus 60 is 120, and then you could have taken that number and turned it into radians this way. So If you don't feel comfortable working with fractions like that, just do everything in degrees and then take your final answer and turn it into radians. Okay, I've done a lot here, so what I want you to do right now is pause it and try this question. Okay, so I'm assuming you've tried the question at this point. So I'm going to subtract 3/2 from both sides. So I have 2 over 2 minus 3 over 2. Oh, my bad, actually. I'm subtracting 1 from both sides. Okay, so minus 2 over 2. So 1/2. So inverse cosine of 1/2. And then you draw your 60 slash pi over 3. And where else can you draw it with the same cosine? Quadrant 4. So now we just need our two answers. So one of our answers is going to be 60 pi over 3. The other answer is going to be 2 pi minus pi over 3. A full 2 pi would be 6 pi over 3 minus pi over 3, 5 pi over 3. So again, if you didn't want to do it with fractions like that, you could have said, okay, this is 360 minus 60, so that's 300, and then you could have gone 300 times pi over 180, and you would have gotten 5 pi over 3. Okay, now, a step with theta. So you might recognize here that this 150 represents h. So it's a phase shift. So in this case, we've gone to the left by 150 degrees. So what we're going to do with these types of questions where there's a step in with the theta is we're going to treat the whole section of theta plus 150 as x. So we're just going to consider that to be x until the end. So what I really have here is 1/5 sine of x equals 0. So same steps as before, divide both sides by 1/5. So I have the sine of x equals 0. And now I'm going to take the inverse sine of 0. And I will get, let's think about it here. Where is sine 0? Sine is 0 here. That's the one that's going to come back to me, 0. But then also 180. But then also, again, back here at 360. Okay, so there's 3 possible answers here. 0, 180, and 360. All right, now I'm just going to make some room here. Let's think about the graph of sine for a second, and why this is happening. So this is 2 pi right here. So here's your 2 pi. So we have 1, 2, 3 times that it's hitting 0 between 0 and 2 pi, including 0 and 2 pi. Now what's going to happen here is that we're going to shift this equation, or sorry, this function to the left by 150 degrees. So like that. So now between this 0 and 2 pi region, we're only probably going to have 2 intersections. But we'll find out. We'll see. So we already said that theta equals, x equals 0, 180, oops, 180, that's ugly, and 360. Okay, so let's set those things equal to our, what is x? So theta plus 150 equals 0. So theta equals negative 150. All right, now I'm going to add 360 to get that answer into the 0 to 360 range. So negative 150 plus 360 is 210. So that's one of my answers. Okay, I'm just going to change colors because that color sucks. Okay, So the next one is theta plus 150 equals 180. So subtracting 150, and I get 30. So there's my second answer. And finally, my third answer is theta plus 150 equals 360. That's a pretty color. Okay, so when I subtract 150, I'm going to get 210 again. This is not a new answer. And there's no way for me to subtract or add 360 to that number to get something different. So we can conclude that our 30-degree answer is right here, and our 210 is right here, and we're all done. By the way, when you're doing one of these problems, it's always good to look at all of the answers that you have and see if you can add or subtract a period to get another answer between 0 and 360. And if you notice here with the 30, I can't do it, and 210, I can't do it. Okay, pause, try this one for yourself. Okay, so I've done a couple steps here to move things along. So we know that the root 3 over 3 is the tangent, so our x is 30. So let's draw 30, and we're finding all the possibilities for x first before we set it equal to theta plus 45. So we're going to extend this line. We got a 30 here. So our other possibility is 180 plus 30, which is 210. Okay, so those are our answers. So now we set them equal to x. So we're going to go theta plus 45 equals 30. So theta equals negative 15. Now that one is not between 0 and 360, so I can add the period. Now, don't forget the period of tan, maybe you want to write this down if you don't know already, is 180. That's important. So when I add 180 to that, I'm going to get 165. That's one possible answer. All right, now theta plus 45 equals 210. So theta equals 165. Oh, we already have that answer. Okay, let's see if we can add 180 to it to get another answer. 345. And those are all the answers between 0 and 360. Okay, this part of the video is for the honors class only. All right, now the tricky part about this part of the video is that instead of having something added to theta, we are multiplying theta. So really what we're having here is an A, which A changes the period. So let's first subtract our 1 just to get things organized. So we have cosine of negative 3 pi equals negative 1. All right, now remember in standardized form we want this A to be underneath. So I know that multiplying by negative 3 is the same as dividing by negative 1/3. So that means my A is 1/3. We only care about the absolute value of A, by the way. Okay, so A is 1/3. My period is 2 pi times A. So in this case, 2 pi times 1/3, which is 2 pi over 3. Now let's think about what that does to your answer. So here's 2 pi right here. Now if the period's 2 pi over 3, that means that I can fit 3 full waves between 0 and 2 pi. So let me try to do that too. Bam. Not bad. All right. Wait, did I get 2? Now I got, oh shoot, only got 2. So proud of myself too. All right, let's try this again. Hey, new strategy. Draw the 3 waves first. Okay, 1, 2, So that's 1 wave, 2 waves, 3 waves, and here is 2 pi. Okay, 1 wave, 2 waves. Okay, good. All right, now the question is, how often does this function hit -1? And we can see that that happens 1, 2, 3 times. So there will be 3 solutions to this equation. Keep in mind, if it hadn't asked us about -1, like maybe instead of -1 it was -1/2, there'd be 1, 2, 3, 4, 5, 6 answers. Okay, so we know we're going to get 3 answers. We also know that the new period, by the way, 2 pi over 3 is 120. That's going to be helpful because when we're finding other angles, we're going to add 120 now instead of 360. All right, so let's go back to our problem here. We are going to replace this whole thing with x. So we have the cosine of x is -1. So x has to be 180. That is the only place on the unit circle where the x coordinate is -1. All right, so -3 theta equals 180. So theta equals -60. All right, -60 is not in our domain of 0 to 360. So I'm going to add a period. But don't forget, the period's 120. So I'm adding 120. So I get 60. Add 120 again. I'm going to get 180. So far I have 60, I have 180, and I'm going to have to add 120 again. And I'm going to get 300. If I added 120 again, I'd be outside of that 0 to 360. So there are my 3 answers, 60, 180, and 300. 60, 180, 300. Okay, let's try another one. So we're going to subtract 5 from both sides. So I have 4.5 minus 5. So I have the sine of x equals -1/2. So I've already replaced that with x. Okay, let's talk a little bit too about this 3 right here. That means a is 3. It's already on the bottom. So my period is 6 pi, or 1080. All right, so let's draw our function for a second here to see how many solutions we're going to have. Here's 1 wave, and that period is 6 pi. So right in the middle here, that'd be 3 pi. So 2 pi, this would be 1.5 pi, so this is like 2 pi right here. There's our cutoff of 2 pi. Now, how many times is this going to be -1/2? 0. 0 times is that going to be -1/2. But let's pretend you didn't know how to do the graphing part and you just wanted to work out the problem and see for yourself. Okay, so we're going to go inverse sine of -1/2. And we're going to get -30 from that. So thinking about the unit circle, sorry, here's -30. Let's draw that again. -30. And so the other 30 would go over here. So really our 2 answers are 180 plus 30, so 210. And 360 minus 30, so 330. Okay, now I'm going to set those 2 answers equal to pi over 3. Theta over 3. So theta over 3 equals 210. So that means that theta equals 630. And then we have theta over 3 equals 330. So theta equals 990. Okay, neither of these are between 0 and 360. And remembering that the period is 1080, there's no way for me to add or subtract 1080 from these numbers that will put me in that 0 to 360 spot. So that's why there is no solutions. Okay, last one. All right, so everything's already in the right spot except for A. So remembering that this multiplication of -3 is the same as dividing by -1/3. So that means that A equals -1/3. And to get the period, we multiply usually 2 pi times A, but in this case, the period's pi for tangent. So pi times A. So pi times -1/3, so -1/3 pi. Okay. Which is also, by the way, 60. Actually, we don't even need the negative there. Our period's not -60, it's just +60. But if I erase that right now, it's going to get all messed up, so I'm leaving it. All right, so let's treat this as an x. Oops. So we have tan of x is 1. So inverse tangent of 1 is going to be 45. And if we think about 45 on the unit circle, extend it out, 45. So the other angle is 225. Okay, now we can do our -3 pi equals 45. So theta is -15, which is not in our correct domain. So what we're going to do is add the period. So we're going to add 60. And we're going to get 45. Let's try the other one. -3 theta is 225. So theta is -75. And we can add 60 to that and get -15. And then you can see we are right here. So if I keep adding 60, I'm just going to get 45, and I'm going to get any other number that I would get just by adding 60 to the 45. So I'm just going to keep working with the other one. So I'm going to add 60 again. So I get 105. Let's go over here. So I have 105. I'm going to add 60. So I get 165. Add 60. And I get 225. And I add 60. And I get 345. Oops, sorry, 285. And add 60, and I get 345. And I can't add 60 anymore without going out at the 0 to 360. So there's 1, 2, 3, 4, 5, 6 solutions. So hopefully that helps, and remember that you can watch this as many times as you want, and the homework will be due next class. All right, bye.